Alright, so in this video, let's prove the DeMoivers theorem using mathematical induction. So, the steps in mathematical induction is that first we need to assume that this principle or this mathematical formula is correct for n is equal to k. That is, it means that we need to accept that the cosine of theta plus I sine of theta to the k is equal to the cosine of k theta plus I sine of k theta, where k is a real number, that is, or k is an integers that is greater than or equal to, that is greater than 1. Alright? So here we can say that hence prove that this DeMoivers theorem hence prove that the cosine of theta plus I sine of theta to the k plus 1 will be equal to the cosine of k plus 1 theta plus I sine of k plus 1 theta. I think we can change So basically our target is to simplify this left hand side, and after simplifying this one, we need to show that our final answer is the right hand side. So let's try to do that. This one, by using the laws of exponent, we have cosine of theta plus I sine of theta. We can actually separate this, raised to k, times cosine of theta plus I sine of theta raised to 1. So this is equal to that. And since we assume that if n equals k, this is true, so therefore we can assume that this is cosine k theta plus I sine k theta is true. Cosine theta plus I sine of theta. And then we can multiply multiplying binomials. So you have there no cosine of k theta times this times cosine of theta, then this 2 plus I squared sine k theta times sine of theta, plus the one with the I component, sine k theta times cosine of theta, plus this one, cosine k theta sine of theta. There you go. And then take a look that I squared is negative 1. This I squared is negative 1, so we can just have it like minus there. So what do you notice here is that cosine of k theta, cosine theta, sine k theta, sine theta, the middle one is minus. That is actually cos, sine, sine. That is actually the expansion of the double angle formula, cosine k plus 1 theta. Right? Which is actually this one. Okay? And then this portion here, this one, is actually sine, cos, sine. That is actually the expansion of plus I sine of k plus 1 theta. So therefore, since the left hand side is equal to this right hand side, therefore by mathematical induction, the DeMoivers theorem is true for all k, alright, that belongs to, oh, sorry, I need to show that this is true for n equals 1 before I make this conclusion. So let me just hold this conclusion here for a while. Let me just show that if n equals 1, this is true, because the mathematical induction, you need to assume that that it's true for n equals k. You need to prove that k plus 1 is true, and then you need to prove that if n equals 1, it really works. So therefore, let's try to show that this part here, well, actually it's just easy to show, because if this is cosine to the 1, alright, so therefore this is going to be cosine 1 times theta is theta. Cosine this sine this is 1 theta, so therefore they are correct. Then I will just, if n equals 1, then the DeMoivers theorem is true. Therefore, by mathematical induction, DeMoivers theorem is true for all values of k that is greater than or equal to 1, and k is the set, k belongs to the set of natural numbers. Or we can just say k belongs to the set of integers. Alright, so there you go. That's the proof. That's the proof of the DeMoivers theorem using mathematical induction. Thank you.